Radius and shielding. And remember, I'm going from 5.6 to 8.3, so it may or may not. Is that similar to the other classes? Ish? Pretty close? Okay. Okay, chapter 8. Radius and shielding or screening increases. You go to the left and down. One trend that goes just this way is the effective. That was related to the shielding when we got there. It's effective nuclear charge, which basically as that goes up, that means there's less shielding. Okay, so as Z is higher, or Z effective approaches Z, that means there's less shielding happening. That's why it's going the opposite way of shielding. For these problems, though, they're generally pretty easy. The whole trend is the chapter is called the periodic law. Periodic law says as you arrange things in the order of a periodic number, or Z, then you see a repeated trend occur. And so all you would need to do as far as the radius goes, or the shielding, either way, I'll just give you a list of a couple elements. So let me give you a couple neutrals first so you get the idea. Let's say I gave you aluminum, cesium, nitrogen, and carbon, and one more, silicon. I'd have you order these in order from largest to smallest. So if we had you go from small to large, what's the first one? What's the smallest? Nitrogen, probably, right? No, you can't see the periodic table. Oh my gosh, look at that. A tragedy. Let's see, where's that button? I guess I'll just tell you the answer while those are making their slow time coming down. Okay. Or, yeah, if you want to think about it, I guess we have some awkward silence right now. Oh, okay, the smallest is? Oh, I already wrote it. Okay, next. Carbon. Yeah, next. Silicon. Then aluminum, then cesium. Okay? So make sure you just zigzag that way. We would never be able to ask you unless one of your instructors wants you to memorize it, not me, but another instructor, like say oxygen and chlorine. You couldn't compare that diagonal. Or you couldn't compare nitrogen and sulfur. The other diagonal, we can't ask you. Okay? That's a trend that we don't know, and that's not common. Okay, but what we could add to this is we could add, say, a cation, like N+, or something like that. That would go where? Yeah, any cation, almost doesn't matter what it is going to be the smallest. It's significantly smaller than any neutral. So likewise, if we had, say, aluminum 3+, no, that's not what I wanted. Let's do silicon minus. Then just by the mere fact that you see an anion, you're just going to toss it here on the largest side. Okay? So anions, the opposite of cation, is significantly larger than the neutrals. Okay? So that's it. If it was shielding, we'd probably only ask you for the neutrals, and for the neutrals, this follows the order of shielding as well. So that's it. It's pretty much all to chapter 8. Any questions on this before I move on? Yeah?
I'm wondering,
where should the aluminum plus, you toss it over here on the smallest side. Or aluminum 3+, smallest. How about the what? Almost any plus, you're just going to toss it on the smallest side. Yeah. Is there a specific order? Usually instructors, are you with me or something? You're with me, right? Then I'm just going to give you one cation, usually. If it's another instructor, good luck. But Usually the higher the charge, so aluminum 3+ is smaller than aluminum 2+, etc. Be something like that.